Next, we're going to talk about chemical bonding. We talked about electron configuration before bonding because the electron configuration dictates how a element is going to react and how it is going to form compounds. In this lecture, I'm going to talk about two key questions. We're going to delve into these deeper in later lectures, but for this lecture, we're going to consider how are valence electrons symbolized and how can the two types of elements, which are metals and nonmetals, interact with each other. First, a quick review of the octet rule, which tells us that each atom strives to have a full s and p orbital in its highest occupied energy level, which is the valence level. The number of electrons in the valence level of an element determines that element's properties, whether it's a metal or nonmetal or a metalloid, and how reactive it is. And just also a review of the what exactly the octet rule is. Recall that an s orbital holds a maximum of 2 electrons and the p orbital holds 6. So together 2 plus 6 equals 8. So 8 is an octet, which is a magic number of electrons. Now again, we do have d and f orbitals, but the filling of these is a little bit more complex, and we're not going to talk about these as much in this class. Okay, so now back to our review of periodic trends. The most major general periodic trend is that of dividing elements into metals and nonmetals. Metals on the left side of the periodic table want to lose electrons because they have few electrons in their valence shell, and they like to empty their shell so there's no electrons there. And nonmetals, which want to gain electrons to achieve a full valence shell. This particular diagram doesn't show metalloids, but metalloids are in between, and they often want to gain or lose electrons. So it's a little bit more complicated figuring out how metalloids will behave. Okay, so we're not going to talk a little bit about the history of chemical bonding. The first person to come up with the idea of a chemical bond was Gilbert Lewis. In 1916, Lewis proposed that atoms can share or exchange electrons, and that it was this sharing or exchanging of electrons that is what a chemical bond is, and that chemical bonding is the basis for forming compounds. Now, Lewis also developed what is now called Lewis theory, which predicts how atoms combine to form compounds. According to Lewis theory, atoms strive to achieve an octet of valence electrons. And I should mention that the octet rule doesn't apply to all elements. The transition metals and lanthanides and actinides have d and f orbitals filling, so they don't obey the octet rule. And hydrogen obeys the duet rule, so it has 1 valence electron and wants 2. So it's, but basically the general idea that chemical bonding is based on sharing of electrons does hold for all elements. All right, so Lewis, in addition to coming up with Lewis theory, he came up with a way of drawing valence electrons that is very useful and is still used today, called the Lewis structure. It's also called the Lewis dot diagram, Lewis diagram. It's got a bunch of different names, but it always has his name, Lewis, in it. Lewis dot diagram for neon is shown on the left. Neon is a noble gas and has 8 valence electrons. These are shown in pairs around each side of the neon atomic symbol, and each pair of electrons represents 2 electrons in an orbital. Nitrogen on the right is from group 5 and has 5 valence electrons. So 2 of these are paired. Those are the 2 shown on above the nitrogen atomic symbol. And then the other 3 are unpaired, so they're each shown alone. Now it's important to draw Lewis diagrams this way with the unpaired electrons rather than having two pairs, let's say, and then for nitrogen, and then one side with no electrons, because this is actually the way the electrons are within the valence shell. We have 3 electrons that exist alone in separate orbitals, and then we have 2 paired electrons. And this is important for the way electrons behave. All right, so I'm going to describe how to make Lewis structures, because this is something that you're going to need to know. So we'll do it with oxygen. So the first thing you need to do is figure out how many valence electrons there are, and the easiest way to do this is to look at the element's group number. So again, this only works for main group elements, and I wouldn't ask you to do this for transition elements. Oxygen is in group 6, which means it has 6 valence electrons. Now that we know this, we're going to start drawing dots one at a time around the atomic symbol. 1, 2, 3, 4. All right, so now we still have 2 more electrons to put in, so now we're going to start drawing a second one on each side until we've got all of our electrons accounted for. So that's 5, 6. Now the reason I do it this way, drawing one lone electron first and then a second one, is this way we have the 2 lone electrons in different orbitals, which is the way they actually are in the molecule. So oxygen has 2 paired electrons, and it also has 2 lone electrons that are each in their own orbital. So when you're drawing Lewis diagrams, never draw more than 2 dots to a side, because each side represents one orbital, and an orbital can't hold more than 2 electrons. And you never draw more than 8 valence electrons, because that's the maximum. So again, this does not work for transition metals, so you wouldn't do this for transition metals. And you can also draw the Lewis diagrams of atoms in bonds, and the rules change a little bit, but we're going to talk about that in a future lecture. Okay, so now we're going to practice drawing Lewis structures for several different atoms. The first one is lithium, which is in group 1, so it's got 1 valence electron. So it's got a pretty simple Lewis structure, just 1 dot. And in a chemical reaction, lithium tends to want to lose that 1 electron. So it has an empty outermost shell. Sulfur is right below oxygen in the periodic table and has 6 valence electrons. Notice the sulfur Lewis structure is identical to that for oxygen. It's got 2 lone electrons and 2 paired electrons. And these 2 lone electrons tend to want to react to form compounds. So, and they can each be involved in a chemical bond. So sulfur tends to form 2 chemical bonds. Now carbon is in group 4, which means it has 4 valence electrons. We draw 1 on each side. So it's got 4 unpaired electrons and tends to form 4 bonds. Chlorine is in group 7, which means it has 7 valence electrons. So there's just 1 that's unpaired, and chlorine tends to form 1 bond. Krypton is a noble gas. It's got 8 valence electrons, so it's got a completely full shell. It does not want to lose or gain electrons and tends to be non-reactive. And the final one is another metal, calcium, which is in group 2 and has 2 valence electrons. Calcium tends to lose these 2 electrons and form an ion with a charge of +2. So just looking at these Lewis structures tells us a lot about how atoms join to form compounds. For example, like I just mentioned, carbon tends to form 4 bonds. Lithium tends to lose 1 electron. Calcium tends to lose 2 electrons. So if you look at the Lewis diagram, it tells you a lot about how, what compounds are going to be formed, and we're going to talk about this more a little bit later. Okay, so I'm going to review what we've said so far. about chemical bonds. Chemical bonds are the sharing or transfer of electrons between atoms. When chemical bonds form, two or more atoms are joined together to form compounds. And the goal of chemical bonding is to fill the electron shells of all of the atoms involved in the bond to lead to a more stable electron configuration. Now we're going to talk a little bit more about different types of chemical bonding. Now remember, there's two different types of elements. Metals, which readily give up electrons, and nonmetals, which want to gain electrons. There are, of course, also metalloids, but we're not going to talk about those as much because they behave in different ways, or it's a little bit more complicated. So we'll mainly focus on metals and nonmetals, which are the most common elements anyway. So basically, there's three types of chemical bonds that can form based on the kind of element, whether it's metal or nonmetal, involved in the bond. First, we have a metallic bond, and a metallic bond forms when a metal interacts with another metal. Then we have an ionic bond, which forms when a metal interacts with a nonmetal. And the third type of bond is a covalent bond, which forms when a nonmetal interacts with a nonmetal.